Okay, so this is geometry and we are at unit 4. This is triangles, content objective 4.5 to 4.8. So for 4.5.1, content objective 4.5, we want to talk about angle bisectors. And in content objective 4.5.1, we want to talk about distance between a point and a line. So here, if I have 2 points, for example, if I have 2 points, if my 2 points are A and B, okay, then what is the distance between the 2 points? It seems like quite direct. I just connect the 2 points, and then I know the distance is this line that I'm currently crossing a lot of little small lines on it, like the hairy line. Okay, so now here's a question. What if I want to know the distance between a point and a line? For example, I have a line CD that is extended forever. And I have 2 points on here. This is line CD. And here I have a line E. Okay, so how do I know what is the distance between E and CD? So here we define that the distance between a point and a line is the shortest length from the point E to CD. So I can get the only distance. Okay, so if I have a point E here, whatever I draw a line from E to CD, I can get this line. Or if I from E to draw a line to line CD, I can get this one. Or I can this one, I can get this one, I can get this one. So that makes it not only, like if I'm going to define something, I want to get the only answer that I can get. So here, this is what is interesting is here that we define the distance from a point to a line is a distance that is actually perpendicular, starting from this point and goes perpendicular to the line. So this way I can get the shortest and only distance from the point to a line. So here, how to prove this is, for example, I have this point that I now mark it brown. So compared to the pink segment, my brown segment is the hypotenuse in this right triangle, and we know the hypotenuse is the longest side in the triangle. So therefore, the distance that is perpendicular from the point to the line is the shortest distance. So therefore, we define that the distance is the distance from the point to the line. Okay, so this is the beginning of the distance between the definition of the distance between a point and a line. Okay, so now here is something very important. What if today I have an angle? Okay, so this is my angle ABC. Okay, so this is my angle ABC. Okay, and now I have a angle bisector. This is my content objective. 4.5 is about angle bisector. Now I have an angle bisector. Okay, so a bisector is a line that cuts something into half. So angle bisector, from the name, nominally is just the line that cuts the angle into half. So I know if this is angle bisector, then my two angles will be the same. Okay, so this is my angle bisector. Okay, so then what is interesting here is if I look at any arbitrary point from the angle bisector, for example, I choose this point, and then the distance to my angle. Okay, now I need to extend the angle. Okay, so the distance from this angle bisector to the two sides of the angle, they will be congruent. Okay, so my drawing is not really good, but this is the property of the angle bisector. Why? Because as you can see, if this point is D, then my triangle ABD is going to be congruent to triangle CBD, because this is distance, this is the distance from a point to a line, so it'll be perpendicular 90 degree, and this is angle bisector, so this is angle also are the same. So looking from this triangle to this right triangle that we can see, and they share a common side, so we can see that this triangle and this triangle are congruent by the RHS property. Later we will address this more. But here what you need to know is this can be proven. So this can be proven. And also the property of the angle bisector is that the distance will be congruent, the same from the one point to the two sides of the angle bisector. Okay, so extend this. Now if I have a angle here, okay, and if I say this is the angle bisector, okay, so this will imply that from every point, if the distance from every point, arbitrary point here, so the distance to the two sides will always be congruent. So that implies that if I find an arbitrary point here, then the distance from this point to the two sides will be congruent. Alright, so this is the relationship between line point and angle bisector.